Set yourself up for an interstellar stunner. In light of the fact that, as per a gathering of researchers, Betelgeuse, the entrancing red supergiant embellishing Orion's shoulder, has previously detonated. That's right, you heard that right. We are not kidding. Inside the following 10 years or a couple of many years, its splendid repercussions will enlighten the night sky. But how did researchers arrive at this claim? Should we be concerned? Might the James Webb Space Telescope catch the leftovers of Betelgeuse? Today, we're plunging deep into all the latest details. Quite possibly one of the most noticeable stars in the night sky in the northern hemisphere during winter is the red supergiant star Betelgeuse. It's among the handful of stars that shine brightly enough for us to see. In fact, its rosy orange tone with the naked eye makes Betelgeuse generally the 10th most brilliant star in the night sky. However, as you may already know, it's forever been known to vary in brightness. Part of the justification for this is that Betelgeuse is by no means your average star. Due to its monstrous size, if we were somehow capable of replacing Betelgeuse with our own little sun, it would extend all the way to the asteroid belt and have a mass of an astounding multiple times that of the sun. It might come as a shock, but Betelgeuse is quite youthful for a star, with an age estimated to be around 8 to 10 million years. In comparison, our own sun is a lot more established, with an expected age of around 4.6 billion years. This is because supergiant stars like this consume quickly through their atomic fuel and go supernova relatively rapidly on geological timescales. This likewise implies they evolve quickly, and Betelgeuse may in reality have done that right before humanity's eyes. To figure out how researchers arrived at the conclusion that Betelgeuse had previously detonated, it's essential to dig into the context. The story begins around the 2nd century BC when Chinese cosmologists made a critical observation that Betelgeuse showed a particular yellow tint. Fast forward to the center of the 2nd century AD, and the Greek stargazer Tycho Brahe described it as orangish or rosy, similar to how it appears today. Comparably, medieval eyewitnesses in the Middle East saw a comparable hue. The inquiry emerges about how colors were named or seen in the past. However, for this case, there is a real possibility that Betelgeuse went through a color change within a couple of centuries. It is conceivable that Chinese cosmologists noticed Betelgeuse during its yellow supergiant stage, and over a few centuries it progressed into the red supergiant stage. Given that people, by our inclination, are night sky watchers, you need to think about the number of individuals across the globe who could see the star and observe the change but left no records. After all, changes to a star like that presumably came with a wide range of darkening and lighting up events that aren't recorded. Imagine them looking up at the night sky and saying, "Hey, didn't that star used to be more brilliant?" And that is precisely what's been happening right now. Betelgeuse is a variable star. However, it appears to adjust to some cyclic behavior. Beginning in December 2019, Betelgeuse's brightness strangely plunged overwhelmingly, which was apparently observable to the naked eye. For those used to looking at the star, it was not its typical self until mid-2020. Over time, it recovered, and one hypothesis was that some of these cycles had harmonized, making for an especially deep plunge in brightness. Anyway, the observations made by the Hubble Space Telescope showed something rather particular. It appeared that Betelgeuse had expelled a massive amount of searing material into space, forming a tremendous dust cloud. This dust cloud, in turn, obscured a huge part of the star's light when seen from our perspective. The change was quite shocking. Betelgeuse, once counted among the 10 most brilliant stars in the night sky, blurred to where it positioned lower than the 20th most brilliant. It was genuinely baffling to observe its dimness in contrast with its neighboring star, Aldebaran, which holds the 14th position in terms of brightness. Fortunately, Betelgeuse gave signs of improvement. However, its unusual behavior did not stop. In fact, it is now showing a state significantly weirder than simple dimming. Over recent months, Betelgeuse has undergone an emotional increase in brightness, outperforming its ordinary radiance by a staggering half. This astounding circumstance is quite disruptive for a star known for its changes. The dimming events could be caused by dust or matching cycles, or perhaps the star generated tremendous sunspots. Anyway, a critical increase in brightness is something else altogether. Despite the fact that it very well may be connected with the past event when Betelgeuse expelled material in late 2019, it probably caused a significant disturbance in the star's plasma flow. The current behavior we notice could be considered a delayed repercussion of that discharge. But what lies behind this exceptional behavior, outperforming the star's normal fluctuations? One moderate speculation that has been widely discussed is that Betelgeuse is approaching the supernova stage. While moderate estimates still suggest that the star is around 100,000 years from today's supernova event, we will provide evidence to scrutinize this thought and show that it has already occurred. So what is the proof? According to a monumental late scientific paper by Hideyuki and Associates of Tohoku University in Japan, Betelgeuse has already gone through a supernova explosion, and we might be seeing the repercussions of this grandiose event in something like 10 years or a couple of decades from now. Yes, that's right. As astonishing as it sounds, the last noticed supernova in our galaxy was the Kepler supernova, which was as far back as the 1600s. Through a thorough assessment of Betelgeuse's variability patterns, the specialists have found 4 distinct periodic changes occurring at time intervals of 2,200, 420, 230, and 85 days. While the origin of the longest period remains obscure, it is estimated to be the crucial period, with the more limited stretches possibly serving as hints. The specialists propose a model suggesting that Betelgeuse is in a late phase of carbon burning, inferring that it very well might be nearly a tremendous blast, positioning it as a notable contender for the next expected supernova event within our Milky Way galaxy. With regards to disentangling the mystery surrounding Betelgeuse, there's a bit of a riddle. You see, there are some conflicting observations regarding the launch of materials and the star's ensuing recovery. The overall consensus leans towards a mass discharge event, something not altogether incomprehensible for different types of stars, albeit on a more modest scale compared to our own Sunday. Yet here is the twist. Supernovae are a real thing too. We actually saw one in a satellite galaxy of the Milky Way back in 1987. So, while it's conceivable that our estimates for Betelgeuse's supernova timing could be off, don't go planning a trip around it just yet. The tricky part is that Betelgeuse is currently interesting to note. It has slipped behind the sun and will not be apparent in the night sky until at least August. Thus, we're left in the dark about what this cryptic star is up to right now. What we do know, anyway, is that it's kicking its normal patterns by lighting up. Now, here's something intriguing. Betelgeuse's huge size and relatively close proximity, roughly 650 light-years away, allow us to determine a plate, in fact, while observing it. Most stars are just too far away, appearing as simple points of light. Yet with Betelgeuse, we have a unique opportunity to capture direct variations in its light output through photography. So we not only have a star that could possibly go supernova, but also plenty of information to gather, including images, even though they might be a bit hazy. Let's imagine the scenario where Betelgeuse has indeed gone supernova. How might it look? Priorities straight. It will be a genuine display, but don't worry. It's completely okay for us here on Earth. You see, Betelgeuse is entirely far away, so it will not really hurt our planet when it goes supernova. However, it will not be the most brilliant object overhead. Really, the moon will still dominate it by a wide margin, and we should not disregard the sun. Anyway, it would create its own shadows around nighttime and remain visible during the daytime for about a year. Now, here's the interesting part. The supernova would be noticeable around nighttime for quite some time, continuously disappearing. There may be a brief period where it recovers some of its previous brightness. However, ultimately it will continue to fade until the recognizable shoulder star in the constellation Orion vanishes entirely. While this supernova won't pose any threat to us, it could create some confusion. After all, some creatures depend on starlight for navigation, and with an extra brilliant light overhead creating shadows, it could throw them off their game a bit. But that's not all. Cosmology itself would face some challenges. Observing the night sky from Earth during times when the moon is shining brightly can be a bit tricky. An exceptionally brilliant supernova would just complicate matters further. Anyway, many telescopes would probably be more keen on capturing the supernova's grandeur than anything else, even if it means changing their observations. Plus, there would be some warning signs before the apparent blast, like detecting neutrinos and gravitational waves from the star. However, here's the central question. If Betelgeuse has already gone supernova, might we catch the remnants? For that, we need to wait for the James Webb Space Telescope to detect the supernova's remains. So how long might it take for Betelgeuse to go supernova? We're not completely certain, but it could happen as soon as next week, next year, or in 100,000 years. In astronomical terms, that's essentially equivalent to right now. After all, forgetting that the light we see from this star is actually very old, and if it exploded 600 years ago, we wouldn't even know about it. What do you think? Might Betelgeuse have already gone supernova? Or is it just showing some unusual fluctuations? Let us know in the comments. The James Webb Space Telescope is obviously the ideal tool for making these observations. We shouldn't have to wait long before it tackles the mystery. Furthermore, for all the effort to understand Betelgeuse's behavior and its implications for stellar evolution, it involves a complex methodology combining observational astronomy, theoretical modeling, and historical context. This star, famous for its variability and immense size, provides a fascinating opportunity for astronomers to study the life cycle of supergiant stars and the phenomena leading up to supernovae. It's fundamental, right off the bat, to grasp the meaning of supernovae in the broader context of stellar evolution. A supernova isn't just a spectacular event. It's a crucial cycle in the life cycle of stars. These blasts play an imperative role in scattering heavy elements throughout the universe. These elements, forged in the cores of massive stars, become part of the interstellar medium and contribute to the formation of new stars and planetary systems. Thus, the investigation of Betelgeuse and similar stars helps astronomers understand the chemical enrichment of the galaxy and the processes driving stellar evolution. Betelgeuse's impending or ongoing supernova event would mark a critical moment in this stellar life cycle. Researchers are particularly interested in the mechanisms that govern the transition from a massive star's final stages to its explosion. Current models suggest that as truly massive stars like Betelgeuse approach the end of their lives, they undergo a series of complex processes, including core collapse and the expulsion of outer layers. These stages are characterized by substantial mass loss, which can influence the star's brightness and variability. By observing Betelgeuse's changes, researchers can gain insights into these processes and refine their models of stellar evolution. Additionally, the historical records of Betelgeuse's brightness variations and its documented color changes offer valuable clues about its past states. However, ancient astronomers' observations, limited by the technology of their time, have provided a baseline for comparing current data. The transition from a yellow tint to a ruddy orange hue over centuries could reflect the star's internal changes and its progression toward a supernova. This historical perspective enhances our understanding of how massive stars evolve and how their life cycles impact their surrounding environments. The potential for Betelgeuse to become a supernova also intersects with our understanding of cosmic events on a larger scale. For instance, the study of supernovae aids astronomers in examining the circumstances leading to different types of explosions, such as Type I and Type II supernovae. Type I supernovae are typically the result of thermonuclear explosions in binary star systems, while Type II supernovae, like those expected from Betelgeuse, arise from the core collapse of massive stars. Grasping the differences between these events can help researchers unravel the history of our galaxy and the frequency of such occurrences. Observational challenges, like Betelgeuse's current position behind the Sun, highlight the complexities involved in studying such dynamic celestial objects. Nevertheless, astronomers employ various methods to monitor stars that are temporarily obscured. For example, they utilize space-based observatories and specialized telescopes to track the star's light curves and analyze its spectral data. These techniques provide crucial information about the star's composition, temperature, and potential for a supernova. Moreover, theoretical approaches, including the use of computational models, play a critical role in predicting and understanding supernova events. Researchers develop simulations that integrate current observations, historical data, and theoretical physics to forecast how a star like Betelgeuse might behave. These models aid in predicting the timing and characteristics of the supernova, offering insights into what observers might expect and how the explosion will affect the surrounding space. The implications of a supernova from Betelgeuse extend beyond the realm of cosmology. For example, a supernova of this magnitude would contribute to our understanding of cosmic radiation and its effects on Earth. Although Betelgeuse's distance ensures that it poses no danger to our planet, the study of supernovae enhances our knowledge of cosmic rays and their interactions with the Earth's atmosphere. This information is vital for understanding space weather and its potential effects on satellite operations and communication systems. Ultimately, the possible discovery of Betelgeuse's supernova remains a source of excitement and intrigue within the scientific community. The event would not only advance our understanding of stellar life cycles, but also captivate the public's imagination. The dramatic visual spectacle of such an explosion, visible for months or even years, would undoubtedly inspire a new generation of astronomers and space enthusiasts. Public interest in astronomical events often fuels educational efforts and promotes scientific literacy, emphasizing the importance of continued investment in space research and exploration. In conclusion, the potential supernova of Betelgeuse represents a significant milestone in our understanding of stellar evolution and cosmic events. The ongoing observations and theoretical work surrounding this star contribute to a broader comprehension of the universe's workings as we anticipate further data from the James Webb Space Telescope and other observatories. The study of Betelgeuse continues to provide valuable insights into the dynamic processes governing massive stars and their ultimate fate. Whether Betelgeuse has already detonated or is approaching that dramatic event, its story highlights the ever-evolving nature of our exploration of the universe and the relentless quest to unveil its mysteries.